Welcome to my presentation. In this presentation, we shall see examples on operations with limits. So, we want to find the limit for this particular function, limit of 2x plus 8. Let me write this a little more clearer. 2x plus 8, this whole thing divided by x squared plus x minus 12, like that, as x approaches negative 4, as x approaches negative 4. Here, the way we want to solve this problem is as follows. In the numerator part, so step number 1, if I were to take the numerator part, 2x plus 8, I can take a common out as 2 and then write it out as x plus 4. That is step number 1. The denominator part, which is x squared plus x minus 12, if I were to use my factoring process, we see that we can factor this one out as follows: x plus 4 times x minus 3. X plus 4 times x minus 3 will come out as x squared plus x minus 12. So we have kind of simplified the numerator part and simplified the denominator part, or factored out the numerator part and factored out the denominator part. And if we were to rewrite the given limit as the numerator part 2x plus 8, we can write as 2 times x plus 4, and the denominator part we can write x squared plus x minus 12 as its factor in its factored form, x plus 4 times x minus 3, and as x approaches negative 4, like that. Now, as we can see, there are some, when we have common terms in the numerator and in the denominator, we can cancel them out. X plus 4 in the numerator, x plus 4 in the denominator cancels out. Therefore, this expression comes down to limit of 2 divided by x minus 3 as x approaches negative 4, In our next step, we're going to write this one out as follows. Step number 3. Since we have a numerator part and the denominator part, we can use our quotient rule here. So we can write it out as limit of the numerator function, limit of 2 as x approaches negative 4, divided by the limit of the denominator part, which is x minus 3 as x approaches negative 4, right? Therefore, we can now substitute the values of value of x equals to negative 4 in the given expression, and then when we do that, it is going to come out as follows. In the numerator part, the limit of a constant number is not going to change anything, so it is going to remain as 2. And in the denominator, we have limit x minus 3 as x approaches negative 4. We're going to substitute the value of x as equal to negative 4 minus 3, like that. So therefore, we have 2 divided by negative 7. When we're using the sign rule, where positive number divided by a negative number is going to be a negative value, so therefore negative 2 over 7 is the value what it simplified to. So when we had an expression of this kind, limit of a function 2x plus 8 divided by x squared plus x minus 12, as x was approaching a negative 4, the value of that limit is going to be equal to negative is it going to be equal to negative 2 over 7, like that. Okay, so let's look at another example. Let's look at another example. In this example, let us say we want to find the limit of this function x squared minus 3x minus 10, the whole thing divided by x squared minus 10x plus 25, like that, as x approaches 5, as x approaches 5. So the way we want to solve it is, we want to break it down into these different steps. In the first step, we're going to look at the numerator part and then factor it. We're going to look at the denominator part and factor it. The numerator part, NR, we'll call it as the numerator part. So we have x squared minus 3x minus 10, and if I were to factor that, it is going to come out as x minus 5 times x plus 2. So let me write this again. Times x plus 2. X minus 5 times x plus 2. When you expand it out using the FOIL method, it's going to come out as x squared minus 3x minus 10. And therefore, if we take the denominator part, which is a trinomial, x squared minus 10x plus 25, and if we use our factorization process, it comes out as x minus 5. It factors out as x minus 5 times x minus 5, right? So therefore, we can put all of these things together and then simplify it some more, and then we, as a second step, we can rewrite the given limit as follows. Limit, the numerator part, x squared minus 3x minus 10, I can now write as x minus 5 times x plus 2 divided by the denominator part, the trinomial x squared minus 10x plus 25, I can write as x minus 5 times x minus 5, like that. And now, if I have common terms in the numerator and in the denominator, we can cancel them out. X minus 5 cancels out. Therefore, we are left with limit of x plus 2 divided by x minus 5 as x approaches 5. As x approaches 5. So I missed that part, so I came back and then rewrote that there. So now, as step number 3, we're going to substitute the values of x equals to 5. And before that, since we have a numerator part and the denominator part, we can use the quotient rule here, and then therefore write this one out as the limit of the numerator part of the function, x plus 2, as x approaches 5, divided by the limit of the denominator function, x minus 5, as x approaches 5, right? So let me write this a little more cleaner, as x approaches 5. So now we are ready to substitute the values of x equals to 5 in the numerator part and in the denominator part. In the numerator part, limit of the function x plus 2 as x approaches 5, we're going to substitute the value of x is as equal to 5. 5 plus 2 divided by, in the denominator part, we have limit x minus 5 as x approaches 5. We're going to substitute the value of x as equal to 5. 5 minus 5. When we simplify this math, the numerator part 5 plus 2 is equal to 7. The denominator part is 5 minus 5 is equal to 0. So anytime we have a number divided by 0, it is going to be undefined. This is undefined. I'm going to write it out below this. we don't have sufficient space there. This is undefined. This is undefined. So that value does not exist. That value does not exist. So therefore, I'm going to put a box around this and then say that is our answer. So what we did here was we wanted to find the value of the limit which had a polynomial in the numerator part, a polynomial in the denominator part as x approached 5. When we factored the numerator part, when we factored the denominator part, and then we cancelled out the common terms in the numerator and in the denominator, and then we came back and then used the quotient rule, the quotient rule of the limits, and therefore we were able to then substitute the value of x is equal to 5 in the numerator part and in the denominator part, and then we came out with the conclusion saying that the numerator part was 7, the denominator part was 0, therefore the value is going to be undefined. So this is how we're going to use the operations, solve examples using the operations with limits. In my next presentation, we shall see more examples with operations with limits.